Good day, people. Today we're going to solve two-step inequalities. So we're going to write and solve two-step inequalities. So Amish has $25 in his pocket to spend, which means he can only spend $25.97 or less. So we know that's less than or equal to $25.97. He wants to buy a paint canvas, and we can see that a paint canvas costs $14. So we know that's our constant right there. And some paint pens. So he's buying more than one paint pen. We know that each paint pen is $3.15. So we know that our coefficient would be 3.15. How many paint pens P can Amish buy? Okay, so let us write our inequalities to start with. So we know he's buying one canvas plus some paint pens for $3.15 each. So that's 3.15 per paint pens. And we know that he only has $25.97 to spend, so he can spend less than or equal to $25.97. So that would be our inequality that represents this situation. From there, we can we're going to isolate the variable. To solve this inequality, we need to isolate the variable. So we're going to eliminate the coefficient to start with. So we eliminate 14 from the left side. So we have to do the same on the right side to keep that balance. So we subtract 14 from the left side. We have to do it on the right side. So we see that 3.15p will be less than or equal to 11.97. To get p by itself, we are multiplying by 3.15 here. So we have to divide by 3.15 on both sides of our inequality to keep it balanced. Dividing both sides by 3.15, we would have cancelled out these 3.15 on the left side. So we see that p should be less than or equal to 3.8. What does this mean? This means Amish can buy, well, there is no 3.8 pens, so the maximum number of pens Amish can buy would be 3 pens. So he can buy 3 pens, he can buy 2 pens, or he can buy 1 pen to satisfy this inequality. And the question also asks, what is the maximum number of pens Amish can buy? So the maximum number of pens he can buy is 3. Alright, let us represent this on our number line. Because if he bought 4 pens, he would have spent more money. He would have to spend more than the $25.97. So the maximum he can buy is 3. Let us represent this on our number line. 0, 1, 2, 3, 4. 3.8 would be closer to 4. So we put a circle at 3.8. We shade it since it can also be equal to 3.8. And we draw arrow going to the left to show that he can only spend 3.8 or less. So 3.8 would be right there. Alright, let us try one more question. The members of the science club are selling coupon booklets for $17.95 as a fundraiser. They hope to exceed, which means they want to make more money than what they made last year. We know that last year they had a total of $658.35. So if they want to exceed that, they would have to make more than $658.35. How many coupon booklets P must the club members sell to achieve their goal? Okay, so we know that they are now at they now have $498.75, and they want to know how much more booklets they would have to sell to exceed that amount. We know that the cost for each booklet is $17.95, so that would be $17.95 per booklet. So this would be our inequality that represents this situation. Let us solve it now. So we can subtract 498.75 from both sides. And we see that 17.95b would be greater than $159.60. From there, we can get b by itself by dividing both sides by 17.95. And we see that b would be greater than 8.89. Alright, let us represent this on our number line. So this would be 8, 9, 7, 6, 5, 4. All right, 8.89 is closer to 9. So we put a circle at 8.89 and we see that it's going to the right. So we, or should be going to the right. They also ask, what is the minimum number of coupon booklets the club members must sell to achieve their goal? So the minimum number of booklets is 9. So they have to sell 9 booklets because you can't sell 8.89 booklets. So the minimum number they would have to sell to achieve this goal would be 9 booklets. So they can sell 9 booklets or more to exceed that amount, but the minimum amount they can sell is 9 booklets. Thank you for watching.